All right, guys, I'll just get you to have a quick look up here. So we went over this question last Thursday, I reckon, so almost a week ago. And I actually made a mistake in one part of it, all right? So I want to correct that, and I want to point out to you the error that we made. And yeah, so this is from the exam last year. There's a couple of questions from the exam last year that we've already had a look at. So we'll just revisit this one quickly. We've got consider the function. It's drawn below. We're examining it between 0 and pi. It says there's two stationary points. We can see there's a local minimum here where my mouse is and a local maximum here. And they're describing that location as x is a. All right, starts pretty easy. State the nature of the stationary point at x is a. So our answer to part A would be local max. Part B says differentiate the function. Find the derivative. All right, so if we have cos of f of x, I'll just refresh you on this, then the derivative is minus f dash of x sine of f of x. Okay, so when we differentiate this function, we're going to have sine of it. And out the front we have the derivative of the inside here, which will be 2 on 5x. Alright, so the negative, there it is. The derivative of the inside becomes 2 on 5x, and then sine of the function. So that's the first derivative. Okay, and then here's, so that's all fine, we were all good there. And in part C, it says, hence using an algebraic approach, determine the exact value of A. So A is a local max, it's a turning point, right? It's stationary. So stationary points occur when f dash of x is 0. And so that's when this function is equal to 0, minus 2 on 5x, sine of 1 on 5x squared, take 1. So it's when this function is equal to 0. Applying the null factor law, we get either this component is 0, or this component, 1 on 5x squared, take 1. Alright, so it's not sine times that, is it? It's sine of that. Okay, so here's one component, here's the other component. Alright, so the solution here is x is 0. So we're not interested in that solution because if we look up, that's not the value of A. Alright, A lies somewhere between 0 and 1. So we're not interested in that solution, so we're going to reject this solution. So we did all this the other day, all this is correct so far. And then we're interested in this solution. And so what we're doing there is we're saying, what we've got is we've got sine of this angle is equal to 0. We're saying what values of theta make sine of theta equal to 0. And if you look at your unit circle, all right, the sine values are the y values, and the y values are 0 here and here. So really there's two solutions, all right? It's when the angle is 0, and it's when the angle is pi. So we're going to have theta equals 0 or theta equals pi. Okay? So we did this as well. So what's the angle? The angle is 1 on 5x squared, take 1, and it's equal to 0 or pi. And here's where I made a mistake, is I rejected this solution because I said it's outside of the domain. But what happens when we actually solve through for x, it shifts this solution into the domain, okay? So what we're doing, if we're solving through for x, we're going to add 1 to both sides, right? So this is what we should do. And so this is the solution that we followed through, okay? But we need this one as well, okay? Then to get x squared by itself, we're going to multiply both sides by 5. And then we'll square root both sides. All right, and it just so happens that if you evaluate this, This is 4.28. All right, and the problem with that is that the graph is drawn between 0 and pi. What is pi? 3.14. So this is a solution, but it's for the next stationary point that's outside of the domain that it asks us to consider. So we're rejecting this solution. This is our actual solution. A is square root of 5. All right, so you still would have got 3 out of 4 marks for it, because it's the algebraic process, right? The 4th mark is for rejecting this solution and arriving at this one. Okay, so when we did it, we were just basically missing this part. So to explain what's going on again, the reason we don't reject this is because when we solve through for x, it shifts this solution so that it is in the domain of the function. All right, so that was my bad. Is that okay? Any questions about it? All right, so differentiator, stationary points when the first derivative is 0. This solution is the local minimum, so then the local maximum has to occur with this one. We solve through. So when is sine of theta equal to 0? Well, it's when theta is 0 or pi. So it's when here's the angle. This whole thing is the angle, right? Is equal to 0 or pi. Add 1 to both sides. So 1 or pi plus 1. Multiply both sides by 5. And then square root both sides. Very good. So that's a good question.